Okay. As you know, our meeting is recorded and will be uploaded to public internet. So chances are whatever you say will remain there forever. With that, let's just start our SIG scheduling meeting. I have a couple of updates for you guys. Some of you have seen a change that I sent, a PR that I sent recently for basically not snapshotting preemption, but not snapshotting the cache before preemption. And I tried to explain what the problem was in the PR, the PR I just sent to the chat link. I tried to explain on the PR what the problem was and why we are not doing the snapshotting. But I don't know if that was clear, particularly since you were on that bug. I don't know if it was clear for you or you have more questions. Please feel free to ask, and then I'll give you some reasons why we did this.
Sure, Bobby. I understood. I mean, the explanation was pretty much clear.
Okay, yeah.
On the PR.
Okay, good. So yeah, the reason that we did this was that it was not working well for, I mean, the logic was not working well for auto scaling, basically. So what we were doing was that we were sometimes setting the nominated node name for a pod, and the pod was being sent back to the scheduling queue, and if it was behind many other pods in the scheduling queue, it would take for that pod to be retried by the scheduler in several minutes later. So this was causing autoscaler to become very slow because autoscaler waits for all the nodes in the cluster to be filled, and then it adds more nodes to the cluster. Basically, as long as there are pending pods that can be scheduled, autoscaler will not attempt to add more nodes to the cluster. And we made this change in order to avoid putting nominated node name for new nodes which are added to the cluster. So this is one example of an area that our new scheduling logic does not work well with the autoscaler, but there are more areas. Once we add the scheduling framework, the autoscaler may not know about all the plugins that the scheduler uses. So we definitely need to make sure that the autoscaler works with the scheduling framework. One possible solution is for the autoscaler to be aware of all the plugins and consume the same config file that the scheduler uses. In that way, it can also use the same set of plugins maybe for running its simulation and basically use the same logic that the scheduler uses. One other area that the autoscaler team actually brought up was gang scheduling. They were saying that gang scheduling does not work well with the autoscaler, and I agree with that. The reason for that is that autoscaler looks at a pending pod, and basically evaluates all the predicates that the scheduler uses and figures out if adding a new node to the cluster could make that pod schedulable. When we add gang scheduling, a single pod of a gang may not be schedulable by itself unless we add, like, I don't know, 10 more nodes, for example, to the cluster, so that all those members of that group, pod group, or as we call them usually in the scheduling world, like gangs, can be scheduled. So adding a single node may not necessarily make a pod, one of these pods of a gang schedulable. So these cause some issues for autoscaling. So going forward, I think we should definitely make sure that any of the proposals that we write for making changes to the scheduler also gets the attention of the autoscaling team. I've actually talked to them, and we're going to add them to our proposals going forward, so that those guys can also have a basically come and review our PRs and give us their opinion about how it works with the autoscaler. So that's something that I wanted to talk about. Yeah, go ahead.
Yeah, Bobby, the proposal, did it get merged? I remember autoscaling team has put the same concern on the PR.
The gang scheduling.
Have approved it, right?
Are you talking about gang scheduling?
Gang scheduling, right.
Right. So yes, that is correct. So far, gang scheduling, the proposal is managed, but gang scheduling is still far from a solved problem, really. So there are other things that we need to address. Auto scaling is just one of them. Another important area is admission control and quota management. Those are not solved problems yet. And the initial proposal didn't cover those. So right now, the proposal is basically only saying that we are going to build sort of a prototype in an incubator project. It doesn't go farther than that. It's just basically we are not going to bring gang scheduling as a standard component. There are some other prerequisites which should be satisfied before we can make gang scheduling as a standard feature or standard component of Kubernetes. And these are some of the items that we need to address before that.
Okay, so the proposal does not cover these areas, but still we have gone ahead and merged it. We just wanted to make sure that the prototype works at this point of time. Am I right?
Correct. So the first prototype was, I have actually the approval comment says that too. So it says that this is good as a starting point for designing the API, and this is good for basically for an incubator that is not a part of a standard company. So that's basically the scope that it's currently in. A proposal is not meant to be like the final design necessarily. Sometimes the proposal is an evolving document that we keep adding and improving.
Okay, yeah, that makes sense. Thank you.
All right, so Claire is here. Claire, you can go ahead and introduce yourself, and we would like to know about you and your responsibilities for 114.
Thanks. Hi, everyone. My name is Claire. I'm the enhancement lead for the 114 release, and I wanted to hop on to introduce myself to the SIG today and check in on existing Kubernetes enhancements that y'all are tracking that might not already be in our sheet. I've gone through yesterday and pinged a bunch of issues, so if I've done that, and you've responded saying it's tracked for 114, it's probably been added to the sheet, but just wanted to double check that we've got everything.
Okay, so Claire, I saw some of your comments. A bunch of our features which are still not closed because we usually go through the process of marking them as alpha, then beta, then GA. Some of them takes a year or maybe longer than a year before getting to the GA, and we leave those feature requests open for that time. Some of them are already built. At least all of the ones that I looked at and you had left a comment on are already built and are already developed and are in our code base. I don't know if you want us to update those as well, or what is the status for those? Because they are in 114 anyways, they are in the code base, and if there's no particular change to the feature, then I'm not so sure if we still need to update them.
Yeah, if there's no change to the feature, there's no need to update. I'm mostly just looking for features that are graduating or new.
Okay. So if we decide to graduate the features, do we still need to do that before January 29th or January 27th? What is, I don't know, I forgot the deadline.
Yeah, enhancements freeze is January 29th, so we would want to know before then. And also as a reminder, all issues we want to have CUPs. So any issue that is going to be graduating, we'd like to have a CUP associated with it.
All right, so a lot of these issues are older issues. They have proposals, not necessarily CUPs. The difference is that I guess CUPs follow a particular format. Some of those older proposals do not follow that format. So for graduation, do you expect those older proposals to be converted to CUPs and reopened? What is the process basically?
Yes, we would want the older proposals converted into the CUP format for those features who maybe were started before the CUP process was formalized.
I see. Even those that are already managed, right?
If it's graduating, yes.
Okay. That adds a bit of overhead to everything. All right, that's fine. So I hope everybody heard that, and if we are graduating anything, we're gonna convert those proposals to caps. Okay, thank you. Is there anything that you want to share with us?
I think that was most of it. If there are any questions that anyone on the SIG has, you can feel free to reach me via Slack. My handle's just Clarence. So yeah.
Yeah. All right. Thank you very much. Okay. So let's go with the other stuff. So there was one issue that basically there was a PR recently sent out. Probably you were aware of that. It was about adding maximum volume, like maximum attached volumes to nodes
Yeah,
for a new, I guess.
sure.
What is this thing that you want to give us an update about that?
Just to give everyone some background, we have like predicates which limit the number of volumes that could be attached to a disk for every cloud provider, for every node when we are using a particular cloud provider. We have it for all the public clouds, but we are not supporting it at this point of time for OpenStack and other private clouds. So one of the reasons that we added was it was kind of a customer request. That's one thing, and the second thing is to bring the limits. Like we want to bring parity because we wanted to have both the public cloud providers and OpenStack, which is by default one of the biggest private cloud providers, or the ones that, or the cloud that is being used for. So we wanted to add that, and in this release, we wanted to deprecate all the predicates, which are cloud provider specific ones. So the PR yesterday just added the OpenStack related volume limits, but in the 114 release, we want to go ahead and deprecate all the cloud provider specific ones.
Yeah.
I know that Bobby, you are kind of concerned with that PR.
Yeah, I wasn't so fond of that PR, honestly, because I feel like the ones that we have already, we should remove. We shouldn't definitely add more to those.
I agree, and at the same time, I made sure that those are like that particular predicate is not a default predicate.
Okay.
And this will be removed in one, like this will be deprecated in 114.
But I believe, I mean, by default predicate, I guess the maximum attached volumes is a default predicate, right? So this is just a part of that existing predicate.
No. Actually, we have the max EBS volumes and max GC predicate, max volumes for GC predicate. All those things are separate predicates that get registered from defaults.go in the package algorithm cloud provider.
Okay, I have to double check. I don't know. I felt like this particular one was adding another maximum for Cinder, I believe, right? So this is very similar to the maximum that we support for AWS and like GKE and other stuff, right?
Right.
So it was. I believe the logic is triggered by the same predicate that checks the other ones. But anyhow,
I think it is not the case, but I'll check that, because in the defaults.co there is an entry for individual predicates too, for EBS, GC, and all.
Okay, all right. Yeah. Anyhow, so our plan is to remove all these cloud provider specific code from the scheduler, and hopefully we will achieve that by the end of quarter or by 114. Okay. Other folks who are working on other stuff, do you have any update or questions for the projects that you're working on? Okay. So there was also one other item that we are tracking, and that's the removal of or limiting the interpod affinity and anti-affinity. This was actually proposed initially by Wojtek from the scalability team on the grounds that the interpod affinity and anti-affinity has a very high overhead for the whole scheduler, including pods that don't use these features. Particularly, anti-affinity should be checked for everything. Basically, the scheduler has to make sure that for every pod that it schedules, it doesn't violate existing pod anti-affinity. And this has a pretty high overhead. So Wojtek was starting this particular thread. Let me see if I can find it. And he was saying that we should probably change affinity and anti-affinity. And so the latest update on that was to add a new feature that basically spreads pods evenly in a particular or in a arbitrary topology domain. So the topology domain could be like a zone, could be I don't know, a region, or any arbitrary labels. So that was one part of it. And then after adding this, we would limit anti-affinity only to node. So that way, we don't need to check the whole cluster every time, and we can only check basically the same node that we are considering for scheduling the pod. Of course, it definitely reduces the overhead of affinity and anti-affinity much, but the concern is that affinity and anti-affinity is a beta API, and many users already use those, and deprecating it could be a big project, honestly. And even if we follow all the standard deprecation processes, which is like in 6 months, we can deprecate it, and all many users could become very unhappy because they have to go and change many configurations in their clusters. So if you also have any concerns about deprecation of that feature, please raise your voice now or say something. We would like to hear all the feedback. So let me.
Yeah, so we have some customers who are using that particular feature, Bobby. So what is the deprecation cadence going to look like? So first you're going to deprecate it, and then...
First of all, it's not, nothing is set or nothing is finalized at the moment. We may not deprecate, we may not go with this plan at all.
Okay.
This is basically up in the air at the moment. And no decision has been made yet. So no, we don't know yet, but if we decide to deprecate it, this is going to be the process. Basically, we are going to announce it. We're going to support it for 2 releases, and then after 2 releases, we're going to remove the support for that and make affinity and anti-affinity, not affinity, only anti-affinity. Basically, we support it only for nodes.
Hi, Bobby.
Hi.
I have a small question related to this issue. Actually, I think one of the most effective approach to improve the performance of affinity and anti-affinity is we can pre-catch this part of calculation before we go into scheduling. I actually know that you have done a lot of work in this part. So I'm wondering if that's all what we can do, or there are still some pre-calculation we can do, like we can set up some index or something like that. Do you have any more ideas about that?
Yeah, I think so. You know, one thing that we definitely can do today is one area that is definitely not ideal is that we go over the nodes in the cluster, and for each node, we store pods that have affinity or anti-affinity. Anti-affinity rules. We don't care about affinity. So basically, anti-affinity is the one which is symmetric. Whenever we schedule a pod, even if the pod does not have any anti-affinity rules, we must make sure that anti-affinity of any existing pods in the cluster is not violated by this new pod. So even if the new pod is not using anti-affinity, we still need to check. So today we have a map for each node that tells whether a node has any pods that has anti-affinity. that map helps, but it's not enough. Basically, if you have only one pod in the whole cluster that has anti-affinity, we still go over all the nodes. We check whether that node has any pod with anti-affinity or not. We can definitely optimize that. We can have another list maybe that has all the nodes with anti-affinity pods, and that probably list is going to be a much smaller portion of the whole nodes of the cluster. This is going to help a lot in larger clusters with like thousands of nodes and very few anti-affinity pods, or no affinity pods, no anti-affinity pods. So that area can be improved for sure. Whether it solves all the problems is a big question. It probably doesn't, and we still need to pay some overhead. Also, if the cluster has a lot of anti-affinity pods, we may still need to go and do a lot of processing for each new pod which is being scheduled in the cluster. So there are still some concerns, but I think we can still do better than what we're doing now.
Thank you for explanation.
Yeah, sure.
So, Bobby, I remember you mentioning about using labels as key, for the map instead of using nodes. That was another optimization that we have discussed some time ago, right?
So labels, you mean, oh, that one is already there.
Oh.
So we have already implemented that, that optimization. That is for, basically that's for checking the predicates, and we have already done that. Anti-affinity or affinity and anti-affinity, both of them were the slowest predicates. And they were like 1,000 times slower than our other predicates. We made a lot of improvements to those. We had like 120x performance improvement. So they are no longer 1,000 times slower. They are maybe like in the order of 8 times slower or 10 times slower, something like that. They are no longer super slow, but they are still significantly slower than other predicates. But that's not the only problem. The bigger problem with anti-affinity is the fact that it's symmetric. The fact that it's symmetric makes the scheduler to check all the pods in the cluster, and that's one of the other areas that is causing the whole scheduler to be slower and affects the throughput of the scheduler for almost everything.
I'm sorry. So my question is more on the lines of, if I remember correctly, the map that you have created and the improvement that we have got is the keys are nodes, right? Am I right, or are the keys are labels?
No, the keys are topology labels.
Labels, okay.
Yeah, the latest optimizations that we've made is that.
Okay. Okay. Yeah. I'm sorry. I was thinking it was on the notes. Thank you.
Yeah, sure.
Okay. Sorry. Another small concern is actually we don't see many users that claim that they are using affinity and anti-affinity in the issue. I saw there are people in our SIG scheduling talking about that. I think we should find a way to include the users in that thread to talk about how they use anti-affinity and affinity. So I think that would be much better.
Yeah, sounds good. So we can actually maybe post this link to our SIG scheduling and ask users to say something if they are not feeling great about this new changes.
Probably Kubernetes dev.
Yeah, Kubernetes dev could be another option for our stuff. So since we're running out of time, and Harry, you're here. So Harry, do you have any updates for us with respect to the equivalence cache that you were working
on? EPR has actually already been set up. I assigned you recently, I think yesterday. You can check that.
Oh, okay. It would be great if you could assign the PR to me.
Yeah, already assigned to you.
Otherwise, I will not probably see it. Yeah. All right. Thank you very much. So is there any other questions or comments? Going once. Going twice. All right. So let's end this meeting. I will see some of you folks next week.
Thank you.
Everyone. Bye.